Okay, here we have a box with a square base and an open top, and it has to have a very specific volume, and we can make the measurements anything we want, but we're supposed to minimize the material that we use, meaning minimize the area, because the area is where the walls are, and that's where we're making out of material. Now, this diagram is very slightly misleading in a way that I'm going to fix right now. They say it's open at the top, which means we should be able to see down into it. We should be able to see that edge back there. That's better. So, this box has a floor, but it does not have a ceiling. And the volume of this box, because it's a rectangular prism, should be length times width times height. But it's got a square base, so we can make it a little simpler than that. This box is S by S by H. So its volume is S squared H. And they tell us that comes out to 108,000. It has to. That's the box we've been taken on to design. And we must make a box that has the minimum possible area. So area is actually the thing we're optimizing. And what's the area for this box? Well, we can't see it from this angle, but this box has a square base, which is S by S. There we go. Also, it has walls, which are S times H. And there are 4 of them, front, back, left, and right. So S squared plus 4SH is the grand total of our area. Now, if we want to optimize this, we want to take its derivative and set it equal to 0 and solve it. But right now, that's a problem because we have 2 variables in here, and multivariable derivatives are a large headache. So can we get rid of one of these variables? Yeah, definitely we can. We can because we have this formula that ties together S and H. If I solve this for H, and I'm doing that just because I think it'll be easier, we get H equals 108,000 over S squared. Or, if you wish, I'm just going to create a little more space here. The other way you could write that is 108,000 S to the minus 2. Okay. So if we have that, that means anywhere we have an H in this expression, like right there, we can put 108,000 S to the minus 2 instead. Here's our new improved area. Area is S squared plus 4S times, instead of H, I'm saying 108,000 S to the minus 2. Clean that up. And we get 4 times 108 is 432,000 S to the minus 1. So that's our area just in terms of S. And we want its derivative. For pretty much any optimization problem, even if you're not exactly sure what you're doing, you can count on it that you're going to have to take a derivative and set it equal to 0. So here it comes. dA ds, or A prime if you like that method, is 2S minus 432,000 S to the minus 2 equals 0. So now we have to solve that, either by factoring or algebraically. Any ideas? It's not anything too nice. Here it is written a slightly different way. 2S minus 432,000 over S squared equals 0. Well, there's not a lot of hope while we have S in 2 different places here, so canceling one of these out would be nice. And I think the most direct way to do that is to multiply the whole works by S squared. In other words, find the common denominator and multiply everything by it. So that term gets multiplied by S squared, this gets multiplied by S squared, and over here 0 gets multiplied by S squared. Now, what does that do for us? Here we get 2S times S squared. 2S to the 3rd power. Here, something good happens. We get S squared over S squared. That cancels out, so we're just left with 432,000. And on the right side, something else good happens. We get 0 times S squared, which is simply 0. So that's a lot better. We now only have one term which contains S. So let's see if we can solve for it. Take the 432 over to the other side. We get 2s cubed equals 432,000. Divide by 2. S cubed is 216,000. Cube root that, and as we all learned on our grandmother's knee, the cube root of 216,000 is 60. So, the measurements of this box are going to be 60 by 60 on the base. And what's the height? We didn't get a height. But we can, because look over here. We got this nice expression that we solved for h. This is just waiting for an s value. It's saying, give me an s, and I'll tell you what h is. Okay, so our h is going to be 108,000 divided by 60 squared. Can't do that in my head right this moment, so out comes the calculator. I get an h of 30. So, if this box is 60 by 60 by 30, which is not at all what the diagram looks like, it means it's a much more low flat box, maybe more like that, then we will get a volume of 108,000 cubic centimeters with the minimum possible area. In other words, we'll use the minimum possible material.